Well, hello again. So we're now starting Trepo in the browser. Beautiful things. So let's see, what's the best way to put this? Where do we start? Start here. So here is the repository for Trepo JS. I think what we're going to want to do is have this work in the browser with Bower and in the and in Node through package.json and npm. So we're going to need to do some ES6 to ES5 compilations and other things like that. Fun things. So what we're going to do, well, here's just kind of starting a local Trepo server in a web worker. Here's kind of what I'm thinking it's going to look like. So you go ahead and import the ES6 module. Then you say, okay, we create a new server. We give it a repository identifier and then some options. And we say, okay, server start. Now, when you call server start, what that will do in the background is it will spin up a new web worker. Actually, no, the web worker will be spun up here. This will actually initialize the web worker, so it will start responding. Take care of any initialization that needs to happen that's not just created a background. We may not need this, but I don't know. We'll find out. Depends on the synchronicity of calls. We'll find that out. And then you can make requests to the server, server.request. You do the method, the path, parameters, and a body if necessary. And then you have a then, and then a catch, and you can stop the server the same way. So the thing is, these are scoped such that we can run n, what are they called? Servers. So we can run multiple web workers, communicate with them, and be just fine. So, and down below, we're going to have an SDK as well. So what this SDK will do is a request comes into it, and it'll map it either locally or remotely. So it'll go to a network or a local server. So what we do is we create just a new instance of the SDK, a new Trepo SDK, pass in some options. And then we can set up a set of mappings. We can say map this repository to this server, which is one of these guys. It says, okay, everything else go remotely and then go this one locally. And then you can do the regular SDK gets and puts and whatever with your promises. And they come back out. So in terms of the code, the SDK is pretty easy. It essentially, you get put post delete, makes a generic request, just maps it to request, and then this one says, okay, if we have something in the map, let's go local, otherwise let's go network, and then local request, this will do all the promise setup necessary. So local request will probably just do server.request, return server.request, which will return a map. So there's a stack, but it's not too bad. So the SDK itself is going to be really easy. We could, at a later date, put objects in there so you get this whole object syntax in the browser. I'm not sure if we want to do that yet or not. Probably not going to worry about it. So the Trepo worker server, so what it's going to do, this is a little interesting. So you have the repository and options. So you spin up the worker there, and then when you start, we post message. The only thing we can do is post a message. We have no metadata we can send, so we need to essentially define a syntax for, it's almost like SOAP is kind of what this is like. It's whatever. So we'll pass in commands and other information. So you got start and stop, and then you got request. This is the fun one. So we don't have a way to make a request and you can post a message, but you can't actually like post a message and wait. Or maybe you can't. I actually need to check that. What does post message return? I'm actually going to look at that. What does post message return? Returns void. Okay, yeah, there we go. So yeah, I was thinking correctly. So because we don't get anything back, it'd be nice if we got like a promise or something that we could get a response. But this is just checking it out. So what we do is we'll create a random ID, like a UUID to represent the request. Very similar to what JSON-P had to do so that it can send a request out, it gets injected into the body, and it can map back correctly, with a unique function call. And then what we do is we set up a promise, and then the promise, we add it to this promises array here. And then when we get data back, when this function gets called, we go ahead and resolve or reject it with this data. And then what we do is we post the message to the worker. We say, okay, we're making a request. Here's the unique identifier, and then the payload with method, path, parameters, and body. And then what we do, I didn't map it. So what we're going to do is this dot underscore worker dot on. Where is it? On message. Is it on message? Yeah. On message. Yeah. So what we're going to do is on message. So this dot worker dot on message equals this dot underscore response. There we go. So when we get a message back, it's going to go to this response, and what that's going to do is, I need some error checking in here, but it'll look for the promises that are outstanding based off of the ID the message comes back in, and then it passes that data in. So it essentially passes that data right here, resolves or rejects depending on the data. So probably want to split this out into its own function, but actually no, because I need it to be an anonymous function because I don't want with bindings. Whatever. Now I can put it. Well, yeah, whatever. So that will make it so that we can go ahead and pass messages. We can link a request with the response. And then on the web worker side, we essentially say on message, we'll switch on command, act appropriately, and then when we're done, we'll post a message with the appropriate ID. And we'll also implement some timeouts, such that if a message comes back, or if we make a request, locally, and it just takes a long time, we can go ahead and short circuit out of that, so we can go ahead and close our request loops. We may also put something in here that every 5 seconds we do some, or 10 seconds, whatever, do some culling of these promises, and automatically reject ones that have been outstanding for too long, and do some cleanup like that, both to prevent some memory issues and just to make sure that things come back eventually, they don't get lost in the void. So that's kind of our web worker syntax there. And yeah, that's it. That's the basics. The next piece is going to be taking this and getting it to work in the browser so we can actually test this callback mechanism, kind of verify what we are pretty sure we know to make sure this works correctly. And then that's it for today. That was a weird and then we will continue on. So we've got the bottom of the stack with Vagabond. We're working on the top of the stack with Trepo, and then we fill in the in-between pieces, which is going to be fairly simple. We'll just put them in the same repository and then map things correctly. So that's it for today. Take care, have fun, enjoy your Tuesday.